Okay, let's get started then. In today's class, we will learn about bare minimal, very basics of R. What is R? What is R Studio? What is R environment? What are some of the basic operations that we can do? What are some of the windows within R environment? What is called a package in R? What are R data types? How to write an R script? And how do we save the work? Basically, the first basic introduction to R. So, as you know, our programming language is really picking up. Right now it is almost up there with the remaining statistical tools like SAS, SPSS, etc. In fact, it is growing rapidly. The reason for that is there are so many packages, there are so many libraries that are being added for data manipulation, statistical computing, graphics, visualizations, etc. And R is fairly easy language to learn. That we will realize over the course of the time whether it's really easy or not. But one thing I can say, it's intuitive. If we follow a particular pattern, we can actually learn it very easily. By knowing some of the essential basics, we can get started with data analytics. The best part of this R programming is that if you learn some of the parts, like if you just learn basics, you can go ahead and start using R. You don't need to finish the complete R developer course. Later on, the more you work on it, the better you'll get. What is a good learning path for learning R? Okay, you start with basics, and then you try to understand how do you handle data within R, importing data, merging data, joining data. So working with data on R, and then important functions and basic statistics within R. So that is how we'll focus. In this session, we are going to learn basics of the environment, coding syntax, etc. So here the assumption of this section, this class is that nobody has any prior experience on working on R. That is how we'll assume, and we'll start from really basics. Okay. What is R? R is an open source. That means it's free to use for anybody. It's a programming language for data manipulations and statistical analysis. It contains numerous statistical methods. There are so many analytical packages that are already available in R. It is supported by a large user network. It has excellent graphic capabilities. It is mostly considered as a language than a tool. When people say R, most of them might mean R language, or some of them mean R tool. So there's a same name. It's a R means it can be language as well as R tool. Okay. R is a comprehensive analytical tool. It can connect to any type of database, and then you once you connect the data, you can do almost all type of analysis. It has most of the statistical algorithms available. In fact, some of the algorithms that are available on R are not even available in some other statistical tools, because most of the research scholars are using R. That means once there is something new that has come up, there is a higher chance that you will find that particular algorithm within R rather than other commercial softwares. R has many more solutions for data handling, data mining, data visualization, text mining, big data, machine learning. You name it, it is there in R right now. If you want to learn data analytics, if you want to get into statistical programming, R is the right tool to start with. Installation of R. Everybody has installed R. You can respond to me by in chat window or by directly saying it here. Installed R, right? You can directly download and install. Installation is pretty straightforward. One thing with R is if you have installed any other software like SAS or any other, even MS Office or Excel, you might have observed that file, that exe file, the program software file was really large, whereas R file is fairly small. Okay, the reason for that is once you install R, you are installing the basic package of R. Later on, we have to keep on adding the packages. The R that we install, that has some basic 30-40 packages. We'll talk about packages little later, but basically the initial installation file of R is quite small, and installation is fast. R Studio, we are going to the through the course, throughout the course we are going to talk about R, but the interface that we are going to use is R Studio. R Studio, what is R Studio? What is difference between R and R Studio? R Studio is an user-friendly UI. Basically, to make the interaction with R little easier, we have this R Studio with us. Basically, RStudio gives us a lot of shortcuts, direct clicks. For importing the data, you don't need to write a really big code. You can just use a button which says import data set. RStudio is also free, open source. Okay. Basically, it is called an IDE. What IDE does, it makes the interaction, it makes coding little easy. Okay. So what is RStudio? It's a kind of skin. It's a beautiful skin over the core of R. So is there any difference between R and R Studio? Not really. Without R, R Studio doesn't work. If you don't have R software inside your system, if you just install R Studio, it will not work. Why? Because R Studio is just a kind of box where whenever you write a code within R Studio, it will be indeed sent to R, analyzed or debugged, executed there. Then you will get the output back within R Studio. So you need R software to make R Studio work. R Studio is just a kind of a beautiful interface that is created for users to make the coding easy. Everybody installed R Studio, or you just installed R? You have to install R Studio as well. Okay. So R programming, in this whole course, we will be using R Studio. But don't think it is different from R. It is just that we are using a easy way of interacting with R. Okay. So let's start with R environment. R environment has three major windows: console, workspace, and output. So let's see where are they. Can you see them? This is console. Everybody open R Studio in your system. Can you see console, environment, that is workspace environment, then output. This is on the right hand side. Sometimes you will see plots, files, packages. So you will see three major windows. Okay. If you are inside R, you will see only console. If you open R Studio, can you see my screen? If you open R Studio, you can see console, environment, and output window. Now the first thing, R console. This is called R console, the one that right now it's being blinking here, the left hand side window. This is where we actually code. Okay, this is where we submit most of the commands. Okay, we write the code, we hit enter, then it will be submitted, the code will be submitted. Okay, if we hit up and down arrows, we can actually see the code that was previously submitted. we can actually write a particular piece of code, then we can use a tab which will tell us, which will suggest us what are the commands that can be written. Okay, basically in simple terms, console is the place where we write our code. Okay, let's do a small exercise quickly, quick warm up. Okay, everybody in your console type these commands directly and tell me the answer. Okay, one by one. Whomsoever is first in the list, tell me, you type this 68 plus 28, hit enter, tell me the answer. Second one, so type these in the console, type these commands in the console and tell me the answer quickly. First one, okay, first answer is 96. Yeah, tell me the second answer. No, no, only one per head. Someone else, second one, quickly. Type 134 into 456, tell me the answer. The reason why we are typing all this is to just get you started with R so that you can feel comfortable later on while working with R. Do not skip all these elementary steps. We have to start from here, okay?
So we can't put a blank line, is it? Every line should have some command.
Correct. So what you are talking about is, what if I want to write a bigger code in a form of a, let's say 20, 30 lines will be there. I want to put the comments and all that, right? So
Yeah.
that is called a script file. We will talk about it little later. Right now it is just giving a command, executing it, getting the output. Okay, to write the whole code line by line and then reusing it again and again, that is called R script file. We will be I'll show you how to write an R script file, how to save it, how to execute it. Everybody finish this exercise? Okay, so help log, the final one, will just tell us showed the description, correct? So it will give you, let us suppose log is a function. If you don't know how to use it, then it'll help is a function that will tell us what does exactly kind of documentation about that particular function that we are entering. Let's say log function, if we don't know how to use it, then we can take help of our documentation using help log. So here is our workspace. You see that environment, right? Here the environment, right now it says environment is empty. If you create any objects, if you download any data set, if you do anything within R, it need to be saved, or if it is saved in an object, then it will be appearing in workspace. Let us suppose I am storing a value called 9 within X, then it will be stored in workspace. So now you can see the value, right? Let's say I'm storing a numerical sequence of 1 to 200. Then the sequence is they are stored in Workspace. This is called Workspace. All the data sets that you have imported, all the objects that you have created, everything, global environment variables, all the things will be appearing in your Workspace. This is R Workspace. Whatever you have created within R, you can see that in the Workspace. The output window, sometimes most of the times the output appears right here itself, right? When you type this command, the output appeared here itself, and one means first element of the output. But sometimes if you are creating graphs or if you are creating something that can't be fit, good fit within this console, it will be stored something like a graph output, a table output, a console output. Anyway, we have seen graph and table outputs. You will see either in plots or sometimes the table pops out. That is the output window. The remaining windows, while we are learning the course, one by one we will see. Okay, but console is the major window here that we are working with. Okay, and if you hit Control and L, you will clean the window. You can try that. If you write any command, submit it, then Control L, you can clean the window. Control L is to clean the window. Now we will start with the basic operator, that is assignment operator. What is assignment? Let us suppose if I want to store a value called 7 within X, then I use this assign. Okay, so this will assign the right hand side value to the left hand side variable. So 7 is stored in X. I just type X and hit enter. Yes, 7 is stored. Okay, let's say Y, 68 plus 20, 96 is stored in Y. Similarly, Z. This is called assignment. I am assigning this value. I am calculating something, and on runtime I am assigning this value to this Z. Then what am I assigning to K? That is nothing but, how do I use assignment? I have to put less than and dash, that is the symbol, hyphen, less than hyphen, or the left arrow mark. Okay. So what is the value of K? This is the one. Okay. So we use this operator for assignment. We can use equal to also, but to have as a good coding practice, we will follow a one method. So we will use this left arrow for the assignment operation. Try this, everyone. Try all these commands quickly. Tell me the answers. Tell me the value of X. Tell me the value of Y, Z, and K after assignment. X is anyway 7. Yeah. Tell me the value of Y, Z, and K. Please be fast. It's very easy, right? Okay. The next one, naming convention. So naming convention, in any language, we need to be careful with the naming convention. We can't define any name. So naming convention, whatever we are naming the values like X, Y, Z, they must start with a letter. They can't start with a digit. But the name can contain a digit. Maybe later on you can define something called X1. X1 is fine. You can have a variable name X1, but 1x is not fine. You can't, define a name like that. Okay. And one of the most important points is that R is case sensitive language. If you define a name as new data, and if you're planning to use it, if you did not put a lot of attention on cases, then you will get errors. Most of you might have seen a lot of languages are already case sensitive. People who worked on SAS or other languages need to understand that R is case sensitive. It will take some time for us to actually digest that, basically who worked on SAS. And then you need to be really careful while working with variable names that you have defined. So R is a case sensitive language. So working with R, okay. So what we'll do is we will quickly write these commands. You don't need to understand what are these commands. This is just to make you uh, very comfortable with R. So I'll tell you what we are doing here. Here we are creating 1,000 values, random values, which are following normal distribution with mean 20, standard deviation 5. If you don't understand what is normal distribution and all that, just leave it, no problem. You just think that we are creating some random 1,000 values. Go ahead and type along with me. So how am I doing it? I'm writing it x, rnorm is a function, x is assigned to r norm, rnorm, and 1,000 values that I'm creating, comma, mean. So these are the parameters that will go into function mean equal to 20, comma, sd equal to 5. The reason why the reason why we are R Studio is because of this. We are getting really good shortcuts. There are a lot of prompts. You can actually find this coding really easy. So I have created x has 1,000 values. So these are all the 1,000 values within x, okay? And then what is mean of x? Go ahead and type along with me. Mean of x, I assign that to m, mean of x, right? Type these commands. Done. Tell me the value of m, tell me the value of s once you're done with this. We are assigning m, we are assigning mean of x to m, we are assigning standard deviation of x to s. Whole. I'm going to the next slide. Is that fine? Okay. Packages. What do you mean by packages in R? So this is an important part of this conversation, that is what is R packages. When you installed R, as we discussed, there are only around 30 packages that downloaded, and you installed only 30 packages. What is R? R is nothing but a big group or big collection of packages. Each package might mean it, you can call it as library also. That is a kind of compiled code which will help us to perform various operations. Let's say if I want to draw a graph, then I have to call a package that will draw a graph. If I want to do some analysis, then I have to call a package that will do some analysis. If I have to calculate the mean, then I should have one package with me. But here the initial package, I mean the initial software that you have installed already, it has mean package along with it. So that's why we did not in particular need to install any package while we are calculating some of the values. But if you are doing some operations that are beyond these, then you have to install the packages. Okay. What is an example? Let's say if I want to draw a 3D plot. Okay. Is that package really available? That we don't know, right? Let's say I'll create 3 random vectors x, y, z of size 1000. So the way that I have created x, y, z here, I'll create 3 random vectors. Okay. So try to create along with me, create x. So here you can use up arrow, down arrow to see the commands that you have already entered. So use up arrows. So I'm trying to use up arrow here. So X is created. Then similarly, I'll use up arrow. Then I'll change this to Y. So sequence Y is created. Now sequence Z. Use up arrow instead of. So I'm creating 3 objects X, Y, Z, and each one of them have 1000 values. You can see X, you can see Y, you can see Z. Each one of them have 1000 values. Okay. Now what I want to do is I want to draw a scatter plot, 3D scatter plot. If you try to draw a 3D scatter plot, scatter plot 3D, say X, Y, Z, could not find the function scatterplot 3D. Why? Because I don't have that package with me. Without, I have only 30 base packages or whatever packages that are there. If you don't have the package, you can't run the code. Then what do? We have to install this package. So I'll go here, packages, install package, type scatter plot 3D. That is a package name. Sometimes this scatterplot 3D might be a function which is part of a different package called graphs or 3D plots or something like that. Then you have to install that 3D plots package. Then only you can run this function. So I am installing this package, install. So while installing scatterplot 3D, it is asking that I have to install one more package also. I said, okay, go ahead. Now it will download and now the package is installed. Okay. Try to run the code. Still it could not find the function. Why? Because I installed the package but I did not attach the package. So installing of the package means the package will come and sit in your library, in your R programming environment. When you attach it, that means by specifying library, this library is also here, then only that function will run. Why this twist? Because over the course of the time you might be installing so many packages. Every time you run R, you might not need all the packages. It's better to attach the package that you are going to use and just leave the remaining packages. Here, am I going to use XGBoost package? Am I going to use SAS7B package? No. Then why should I attach them? I'll attach only scatterplot 3D. Now, since I installed the package, I attached the package, I can run the code. Now the 3D plot has come. Everybody understood what are packages? Packages are nothing but the compiled codes. If a particular package is missing, then you can't run that particular code. Go ahead and try to do this exercise. Create 3 random vectors x, y, z, size 1000. Use R norm to create those vectors. Draw 3D scatter plot. Try to do this quickly. Once you are done, please let me know so that I can go to the next slide. As soon as you are done, just put it in your chat window that you're done. This is to get an understanding on packages. If you don't have a package, how to install package. You can manually install it or you can write a code. You can manually attach it using GUI or you can write a code to attach it.
Library path taken is something different under temp folder. Can we reassign it?
Uh, that is a temp only. It will get deleted anyway.
Okay,
And
sure.
once we install the package, R will take care of the rest of the thing. If you change that, whenever you are giving this library, okay, let's say if I give this library statement, R will by default go and search in that particular place. If we change it, then we have to give the mention the path also here. Okay, this is a package and you have to get it from here. Yeah. We can change it, not a problem. But automatically it takes, we don't need to change it every time unless we want to save it and store it with us. Done everyone? Okay. So what are some of the useful packages in R? There are nearly 7,000 packages in R and they are counting. As we are talking, maybe one or two new packages are being created. That is the reason why R is becoming famous every day, because there are so many third-party packages that are coming up. They are making very small, algorithms are also, okay, very user friendly, and everybody has an option to actually download any type of package and use it. So there are so many packages that are already available in R. They are still counting 7,000 packages for doing analysis and etc. Same task, maybe just creating a graph itself. You have so many packages, so you can create beautiful visualizations if you use the right package. For visualizations, we can use ggplot2, ggvis, rgl, html widgets. There are so many packages just simply for graphs. In other softwares, maybe for graphing you will have one or two options or one or two packages. Here there are so many packages. Some people or some companies just creating R packages and giving them, making them open source. Then there are some advanced analysis packages, data handling packages. So you just name what the operation that you want to do, you can find a package for that, almost all of them. If the package is not available, then yeah, some our community might be developing it soon. Are data types. Okay. It is very important to understand data types before we start any type of programming language basics. So what are the data types within R? Vectors, data frames, lists, and other types are matrix, factor, and array. So we will talk about each of these data types in detail. R vectors. So R vectors, vector is the basic form of the data type in R. What is a vector? It's a collection of multiple elements. Okay, so what exactly a vector? A vector doesn't mean it just a single value. There can be more than one value within just one object, one vector object. So by default, everything in anything that is newly created is a vector. What do I mean by that? Let's say I'm creating a new object or a new variable called name. So name and my name. Okay. Is it a vector? I'll use a function called is.vector which will test this variable name. Is it a vector? It says true. This is a vector. Okay, I have created a string variable. It says it's a vector. Then I'll say age, which is 20. Is it a vector? Yes, it is true. The first one is a character vector. The second one is a numeric vector. You might be asking, there is just only one value. Why are you calling it as a vector? This is a single value vector. There can be multiple values within the same vector. Let's say age can be like this also, right? So we use something called C operator, concatenate operator, okay? C of 15, 17, 16, etc. So age is created like that. Now age has 5 elements inside this. So age is a vector. So everything that is by default created is a vector in R. Why is so? Why it has to be a vector? Why not be a single variable? There are specific reasons for it. Handling vectors and doing the calculations using the vectors becomes very easy, fast, and lot of loops can be removed. Once you remove loops and iterations from your calculation, I mean, once you solve them quickly, then most of the times the algorithms run quickly. The reason for that is, later on you will realize the value of using everything as a vector. But please remember that everything that you create within R is a vector. So I have created a variable called age, which is a vector. So everybody go back and type your name, just test it whether it is a vector or not. Quickly type create name and age, just test whether it is a vector or not in your own environment. Name, assign your name to name, check whether it is a vector or not. Assign your age to age, check whether it is a vector or not. Once you're done with it, go here. Create these vectors, create these 4 vectors, then test them whether each of them is a vector or not. Are you doing it? Age, create a vector age, use concatenate operator. Create a vector English, use concatenate operator. Check whether it is a vector or not. Shall we move on? Okay, once you have checked first 2 of them, that is fine. Now why we need to use vectors? We already discussed about it. Why we need to use the vectors? Let's say you have already a vector variable called age, right? Now, in general, if I want to add 3 to each of these elements, imagine age has 1,000 values. If I want to add 3 to each of that, then here simply you can write age plus 3. These operations are very easy. Age plus 3 and everything, every element of age is added with 3. Okay. Or if I want to do any other operation, it becomes very easy to handle the vectors. Let's say I want to create a new variable called English 1, and what I would like to do is English plus 10. So English 1, this is the value 50, 66. Basically, I added 10 to each of the variable. Then I'm creating a new variable called total. Go ahead and do it along with me. So basically, what is the advantage of vectors? You can write a lot of iterative operations without actually using loops. So what is the real power of vectors? Look at this. There is a variable called x, okay, that has 1,000 elements, okay. From each of these elements, I want to subtract the mean of this whole x. So what I want to do is, from, let us say if it is 17, I want to write 17 minus mean, 19 minus mean. So instead of doing individually, I can just simply say x minus mean of x. So I have subtracted mean from each of the elements. So you don't need to write a loop that will go through each element and it will run 1,000 times. It is faster. So that's the reason why it is using vectors. Go ahead and do this. Okay, once you're done with these operations, we'll go to the next slide. Accessing the vector elements. Are you done with this, everyone? You created total age divided by total. So basically we can create a new variable called total. Then basically all the operations, you don't need to write any loops. Then age divided by total, something like that. So I'm using x r norm 1000, mean equal to 20, sd equal to 5. This is x. We'll take a 5 minutes break here, then we'll regroup. Okay, can you hear me? Okay. Accessing the vector elements. Each vector has multiple elements, right? How do we access each of the element or a specific element? This becomes very important while you are working with data sets later on, because every time you import a data set, it will be imported as multiple column vectors, and then from each column, if you want to extract particular rows, then you need to know how to access the vector. So let's say this is my vector. Let us suppose I just want the third element in this vector. Let's say a third student's age. I'm not interested in anything else. So you need to put square brackets and then 3. That is how you access. What if I want to access the elements from 3, 4, 5, 3 to 5? So I will say 3 is to 5, 3, 4, 5. What if I want to avoid the second element, get everything else? That means I want first, second one I want to avoid, third, fourth, fifth element. Then I have to put a minus symbol, negative 2. That will just avoid the second one. I can access all of them. This doesn't mean we changed the value or the object age. Age is still having all the elements. We are accessing or we are printing only these 4 elements. If I assign it to something else, let's say if I assign to something like age subset, then if I write it like this, then age subset will have only 4 elements. Within this, let's say age, the third element is 16. Actually that was misspelled or wrongly typed. If I want to update it as 19, I can access it, third element of age, overwrite with 19. Now if you print age, it is changed as 19. Similarly, fifth element, I want to make it as 21 or 20, then it will be updated, it will be changed as 20. This is the new age. Okay, everybody try these commands quickly. Let me know once you are done with this accessing the vector elements. So what if we want to add a new element to age? Let's say you want to add uh, you want to add the sixth element. Okay, age has 5 elements. You want to add a sixth element to age. Okay, you can say 6 and then what do you want to add? 21. Yeah, now age has 6 element. Does that answer the question? What if we want to add a new element? Okay, there are two types of vectors may largely, that is, if you take age, that is a numeric vector. If you take the other type of vector, that's a character vector. So these are the two types of vectors. On character vectors, obviously we can't do any arithmetic operations. But sometimes if you see any error, regarding the type of calculations. If you get an error saying that arithmetic is not possible, just check the class of the vector, make sure it is numeric. Okay, that is about the vectors. Then the data frame. What is a data frame? Data frame is nothing but, just give me a, data frame is nothing but a data set. So within our data sets are called as data frames. Once we import a data set, then it will be imported as a data frame which will have rows and columns. So from external files we import the data set. In fact, generally this is not the way we create the vectors. This is not the way we create the data. This is just for practice. We have taken it. But in general, the way the data is created is we have to import it from external files. Once it is imported, then it will be stored as a data frame. Then we can actually use the data frame, or we can manually create the data frame as well. But we will directly see, that importing portion later on. But now, for now, we will work with a data frame and how to access the data frame, etc. Now we will manually create a data frame. We will not import anything. We'll manually create one data frame. We have name, vector, age, English, and science, right? If you haven't yet created, create them now. So these are the four vectors. Create these four vectors if you haven't yet created. Each vector should have the same length. Age, if you had added the sixth element, rewrite it, rerun this thing, you will get 5 elements back. Okay, this is the age vector, this is the English, science, name, right? These are the four vectors. Create these four. Once we have these four, then we can create something called data frame. We can create students data frame. How do I create students data frame? I need to use a function called data frame and then just write name, age, English, marks in English, marks code in science. This is going to be a data frame. It and we are storing it inside a data frame name called students. Okay, so students data frame is created. Can you see that? Students data frame is created here, right? So I have age, English, science, name. These four are the vectors. Using those four vectors, I am creating a data frame. You can see the students data frame. You can print it as well. Everybody created this data frame. But in general, this is not how data frames are created. You will need to import it from the external files. This is just for our practice. We are creating a data frame here using the four individual vectors. We have tied them together to make a data set. Now accessing each row and column in a data frame is what we are going to discuss. That is possible only when you have a data frame with you. Once you have students data frame, please let me know. Once you're ready with the students data frame, please let me know. Everybody ready with this data frame? Not yet created? You want the code? Done. So here is the code to create each of the vectors. Once those vectors are created, here is the code for creating the data frame. Done. Now how do we access a row or a column or a particular element in the data frame? Let us suppose I want to, okay, this is a data frame, students is a data frame or a data set. Imagine you have a data set with lot of rows and columns. You want a particular row. You just want only names of the student. You just want only age of the students or a particular score of a student. So what you need to write is, if you want to access it, it's very important. Please take a note of it. You write the data set name, dollar. It is giving you the options for what are the variables that you can access. Let's say I want to access name, students dollar name. These are the names of the students. Students dollar age. This is the second column. If you want to access only second column, if you want to access only third column or fourth column, this is how you write it. So you have the dataset name, dollar, variable name. The first variable is a character variable. It is read as a kind of, that's why it appears differently. Remaining all are numerical variables, right? This is one way of doing it. There is one more way. You can write the name of the dataset within square brackets. You can write name of the variable. This is also accessing the same column. So if you want to access the column in a different, this is an alternative way. Alternatively, you can also access a particular column using this code. Do it, write this code. First try to access name, age, the third variable and fourth variable using dollar, or use double quotes. You're done using double quotes and using the variable names. Okay. Now there is even one more way. This is the most widely used way, or it generally intuitively the better way. You say students, the way we access the vectors, which are unidimensional vectors. So what if a data frame looks like a bidimensional, it has rows and columns. You will just have one comma everything. What does that mean? First row, every column. What about this? First column, all the rows. What about this? Second column, all the rows. What is second column? Age, right? Age is second column, all the rows. So basically, if we say students data set, and then the first one is rows, second one is columns. If I say first row, first column, then that is the answer, John. Second row, that is second row, first column, that is the answer, Bob. Or second row, second column. So that I'm talking about second row, second column. So I'll get answer as 17. That's how you can uniquely, or you want all the rows in the second column. You want age, everything, all the rows. That means you just leave that field blank, and the second column if you mention like that, then you will get full age. You want all the rows third column, all the rows fourth column, right? Similarly, all the columns first row, all the columns first row, all the columns first two rows or first three rows, 1, 2, 3, all the columns. What if I want to avoid a particular column and get everything? I want to avoid the first column. So if you put -1, it is same as saying I want to get it from 2 to 4. So instead of saying ignore 1, get 2 to 4, you can just say -1. Similarly, the -1 will, I want all the data set, everything in the data set except the first row. The first one is rows and columns. Very easy to remember, rows and columns. If you put minus sign in front of the row, it will avoid this particular row. Try to type all these commands. Let me know once you are done. First print students data set. Write all these commands. Once you get the answer, just go to chat window and tell me once you're done.
Can you explain the last liner, last command? Why we used C of 1, comma 4? Guess you are on mute.
Sorry, yeah, I was on mute. Okay, let me repeat once again. So we have a student's data set. We have the student data set. What my requirement is here, I want the full data set, but I mean full rows, all the rows, but I want only first column, that is name, and second column is science. That's it. I want to ignore these two columns. Okay, I want selected columns. Imagine 400 columns are there. You want the 80 and 95th column. Got it? So how do I get it? So intuitively speaking, I'll write it this way. I'll write all the rows. That will serve all the rows, right? Then I'll say first column, comma, fourth column. If I write like this, I don't get what I'm intending to do, right? What I want is, I want first column and fourth column. I want to ignore rest of the, so some selected columns. So I need to pass this argument using concatenate operator. Okay, I can't just write it directly like that. I have to use concatenate operator. Whatever columns you want, you just mention them and then pass it on to R. This will fetch me, this is what we want, right? Like we wanted first column and fourth column with all the rows together. So the way we should fetch it is, if you want selected columns, you just write within C what are the columns that you want to select. Got it? Similarly, If you want selected rows also, you can do it that way. You want the uh, second row, fourth, comma, fifth row. You can get it like that. Okay. Basically, if you want to give multiple indexes in one go, you can club all of them and inside concatenate C operator and give it to R.
So in the similar lines, can we print every even number of observation from a data set?
Yeah, for
I
that
mean,
we need
in
to
case,
write a logic kind of thing. It's not like directly C mention. Hard coding is not a good thing. Okay, there is a way the sequence is there within R. Okay, 1 to 50. Like that, there is a way we can skip every second one. Yeah, printing even, printing odd, all that logics are available. We just need to write the
okay,
right logic. That's it. There are
okay,
specific functions for two table, three table like that. So we can use them. So inside C, you mention them, then it'll uh, take that. I think there is something called a sequence function. So we can use that. So we can create a specific sequence of even numbers or odd numbers, and we can give that as an index. Shall we move on? Okay. Now you might have seen you have accessed the data frame, same column, you can access it using dollar, you can access it using square brackets inside the quotes, you can access even in a matrix index format. Is there any difference in the final output? Yes, there is difference. We need to be careful with this. Okay. Let us suppose you have three variables, three objects. Okay. In that, you're doing pretty much the same operation. You're getting something called name. So X is name, just a particular column. So within students, okay, I have taken one column that is X. So this is output, right? Now Y is also like that only. Within students, I'm taking Y, but not in that way. I'm taking it this way. Ideally, they both are same, right? This is Y, right? Both are same. I just took the first column. Then Z. Z is also the same thing that I'm taking. Within students, I'm taking it as every row and one column, first column. Z is also same. What is the difference? What is the difference between X, Y, Z? The way they structured, the way they formatted is different. X might not be a data set, it is just a normal object. So see the structure of X. It's a factor, it's a kind of, factor is a new kind of data type for us. It is simply an object, okay? Whereas what is structure of Y? It is important here. Y is a data frame by itself. You took an subset of the data and sometimes you want that subset to be a data set. So if you want the subset to be a data set, then you can call that, you can take that subset by using these quotes. What is the structure of Z? Again, it's a factor. So basically the structure might be slightly different. Now do we need to remember this? No, we don't need to. We can use any one of these, but later on while you are doing any operations, if you find some error which says that we are expecting only data frame and all that, then you can change the way you are trying to refer, you are trying to subset the data. You just need to keep it in, you just need to remember it, and then later on while you are using it, then try to see changing the way you are accessing the data frame. Try this quickly. Write the code as it is. Moving on, there are some built-in data frames inside R. What are built-in data frames? If we want to do any of the exercises or sample data sets that are available inside R. When you first installed R, uh, you have already installed a package called datasets. Yeah, str stands for string. Yeah, the type of the class is same, but the way it is structured is different. So there are some built-in data sets within R. So when you install a package, you also installed a package called datasets package. So let's say if you type data, so you just don't need to give anything. You just type data. Then these are the data sets that are already available in R. If we want to use for any of the examples or practice, we can use these data sets. Okay. So this particular data frames, they have something called air passengers data. If I want to just type air passengers data, this is air passengers data from 1949 to 1960, from January till 1960 December. There is something called cars data. What is this? Speed and distance of stopping. So if you want to know what exactly is this cars data, you can just put question mark. Question mark stands for help. Okay. Writing help inside cars, help of cars, opens the documentation, is same as question mark cars. Okay. Speed and stopping. If you just want to know what is that data set, okay, so it will give you an idea on here that what exactly is that data set, what is the, what is the way we should use it, etc. Those are built-in data frames. Let's do this quickly. You need to write the command data to see all the data sets and then print any of the data set. I'm printing cars, printing air passengers. Moving on, lists, list, list. A list is a collection of R objects or components. Okay, what is a list data type? List is a hybrid data type. That means a list can contain first element of the list can be number, second element can be character, third element can be a data frame, fourth element can be an image or something like that. So list is a hybrid data type. So what exactly hybrid data type? Okay, uh, let's say try to do this quickly. You have a first one which is x 1 to 20, then print x, that is 1 to 20 values have been imparted in x, okay, stored in x. Y is a true false, it's a boolean variable. Okay, write it along with me. First create x, then y, create x, c 1 to 20, y false. Z is a string variable, it is a mic. K is a numeric variable, 30. L is a data set. Remember students data, student data set, L. Why not accepted? Did you give quotes? If you are giving within quotes or, okay. Suresh is saying that when he says Y false, it's a boolean one. Is it accepting? Are you facing the issue? Still now?
Yeah, in the same command it's not taking.
Did you try y true?
I think if I'm passing within quotes, it's accepted.
Yeah, that is string. That will be string. What I want to do is
Mm.
I want to create a Boolean variable, true, false kind of thing.
It's not accepted for some reason at my end.
Okay, here you have given all caps, right?
Yes.
Okay, so try using the tab prompt, right? FA and see this. Can you see the logical this thing? Do you know how to get this prompt?
No.
You have to write first two letters and then hit tab.
It's not displayed
It's
false.
not displayed. Okay, that means the
One
logical
second.
variables
One
are
second.
not.
Hold on. One second. Now it's taking.
Okay. Yeah.
Yeah, all good thing.
Okay. So create one by one. Create X. Create X. Create Y. Create Z. Z is a string. Create K. Create L. L is a data frame, by the way. Students is a data frame, right? Okay. Cool. So then I am creating a new variable called description disk. This is a list of all my R elements, right? So these are now focus here. These are all different type of data types. What is the first one? What is the structure of X? It's an integer. It's an usual integer vector. What is structure of Y? It is a logical value, true false type. What is structure of Z? It is a character or a string. Okay. What is structure of K? It's a number. Okay, which is just 30 numerical vector. What is structure of L? It's a data frame. We know that, right? Now what I'm trying to do here is I'll create a list with all these, like first element of list I want the description, second element of list I want something else, third element, fourth element. Within this list I want to have the data set also. Within this list sometimes I want to keep an image, sometimes like, so basically what I'm trying to do is my list is a new list name. Then I'll create list using list function list. I'll use description which is defined already, X which is there, Y, Z, all of them are created, K is a numerical value, L is a data set. My list is created, list of 6. Can you see that in your environment? Now what is the use of this? Sometimes what happens, you want to bundle everything. You want to bundle a data set along with its results. You want to also include a table in your description. Send it as a proper bundle so that, okay, first element of my list, okay, or let it be my report or my analysis, okay. First element, let me access the first element. That is the description. Second element, okay, what is it? A string of numerical vector of numbers. Then what is the last element? Okay, fifth element, that is a number. Sixth element is the data set. If I don't mention anything, if you just put my list, you will see all the elements in this list. So this happens specifically when we are running some statistical algorithms later on. The output might be really big. To access specific parts of the output, okay, what if I want the second element, like within list there is this second element, or within list the sixth element is data frame. Within that data frame I can access the column. So basically you can arrange it in a really good hierarchical manner, and you can keep everything as a bundle. So that's the reason why we call it as hybrid data type. List doesn't have any specific data type. You can't call it as a string, or you can't call it as a data frame, or it's a logical. No, it's a combination of everything together. Clear? Accessing the list element, we have already seen what is the structure of my list. What is the structure of it? It is called a list. That's it. Okay. You want to print my list, you print it. It will be printing all the values. So how do you print the first element of my list? How do you access the first element? You just say this is the first element. How do you access the second element of my list? That's how you access the second element. How do you access the second element of the second element in the list? What do I mean by that? What if I want to print this one, or what if I want to print this one? So first I'll go to the second element, then try to access the third or second element within that one. Now this will throw an error because we need to freeze the second element first. So I'll freeze it by mentioning double brackets. So second element is freezed. Now within that, now you have actually zeroed it on a kind of a particular element within the list. Within that, if you go for the second element, that is 2. Is that clear? Go ahead, write these commands. Create my list first, everyone. I think you have created it. If you haven't yet, use list command. Create it. Once you have created it, use the accessing of list. One more example of the list, because most of our outputs later on in this course will be in the form of list. Okay, this is just an example. You don't need to try it. I'll just display it. There's this cars data set. Okay, it has speed and stopping distance. Maybe later in the course we will learn something called regression. Let's say if I run a regression model, okay, I'm fitting a regression model. Okay, you don't need to understand what exactly is regression model. So I'll just say I'm fitting a regression. It's a kind of statistical model that I'm fitting. Okay. So REG is my output. Okay. This is a regression model. What is the structure of REG? So the output structure is list. It has so many things inside it. Structure of REG. Now if I want to access specific elements of this output, regression model, what is the first element of this output, because it gives a huge output, that is a statistical output. So we have created REG, right? REG1. The first element is coefficients. If I am just interested in regression coefficients, I can take it. What is the second element in this output? Second element is residuals. What is the third element in this output? Third element is something else, effects. What is the fourth element? So an output can contain multiple elements. So that is the reason why we are, learning about lists in R. They are very handy when you are doing an operation that might generate a huge output. It is easy to structure it. It is easy to arrange it in such a way. Even within these each element, you might contain specific again further elements. So within 7, this seventh element, there are even further element. So within 7 we will freeze it. So that is the first element within 7. Okay, that is just an example of list. Factors and matrices. By now you have seen already 3 types of data types. First one is vectors, right? Then we started with data frames, then we went to lists. Then there are other two types of important data types, that is factors and matrices. You might be wondering what is the need of learning the data types and all that. Maybe once you are doing all the coding later on, okay, if you are not clear about what kind of data type you are working with, if you don't know the difference between vector and a factor or vector and data frame, you will not be able to understand the error that is displayed on the R, or you will not be able to understand the documentation because they are talking in terms of the technical words like, okay, this is a vector, you can't apply this operation. This is a data frame, that's why you can't do this, okay? Or this is a list, it doesn't have a particular specific data type. That's what they say. Then you will be wondering, like, you know how to write the code. If we would have directly jumped onto code and start writing it, if you don't know what is what later on, it will be a really big mess. That's the reason why it's very important that we are very strong in our basics, so that at least we can understand the documentation, type of the error, compilation, debugging will be very easier, and you will be working with this tool smartly rather than just blindly trying to search the answers in Google. Okay, so are factors and matrices. What are factors? Factor is a kind of categorical. So strings are there. Factor is a specific or special form of strings. It's called categorical variable. It will have categorical values, or it will have, let's say, east, west, north, south. Okay, if a variable name is region, it takes values east, west, north, south. Then that is a factor variable. It has different classes. So why R has why don't we just call them as strings? Why we have a different class called factors? So for additional operators, like for additional analysis, okay, defining something which is a categorical variable or a factor type variable makes it very easy later on. I mean, it's very efficient to use factor variables rather than just string data type. String is for usual string. You know what is a string, right? For usual character variables. Within character variable, there is a specific type that is called categorical variable. So that is called factor. Okay, later on if you see factor, you understand it this way. Okay, it may be containing something like classes. Okay, 1 2 3 4 classes. It has different levels, 1 2 3 4 levels. Okay, it's not numerical, it's non-numerical, or even if it is numerical, 0 1 2 3, that is also a factor which is classified. 0 is a kind of coded value. Maybe 0 is one class, 1 is one class, 2 is one class, 3. So 0 1 2 3, there are 4 different levels in that factor type variable. Okay, matrix, multi-dimensional array. Sometimes the calculations can be very quick when we use matrix data types. In some, maybe, right, if you are really good with R, later on you might be using matrix data types to write the code efficiently or execute the code efficiently later on. Okay, here are the factor examples. Just go ahead and write this code. So if you directly see structure of gender, it is giving as a character variable. Now I'm converting it to factor. Why am I converting? Maybe later on for categorical related operations, factor is the better way. So now this is a factor with two levels. Okay, finding the frequencies, finding a histogram and other tables. Okay, doing calculations at each level wise becomes very easy when the variable is of the type factor. Even we can have numerical factors. Here is a numerical factor, result pass or fail. We are coding it as 1 comma 0. In general, there is this, if you see the structure of the result, it will be obviously taken as numeric, right? But I want to make it as factor. These are not actually 1 0. These are two classes. Then what I'll do, I'll create something called result 1 from factor result. What is structure of result? Oops. Structure of result is vector. Structure of result 1 is factor with two levels. Level 1 and level 2. Is that clear? The reason why I'm
Can you cover? Sorry.
yeah,
Can you
tell me.
cover again the difference between string result and string result one?
Okay. So you're talking about the second one, structure of the result and structure of result 1, right? Okay,
Yes.
let us suppose I take result. This is the value, right? RESUL. This has just 1 0. Okay. If you take structure of result, okay, this is a numerical vector. It's simply, it says 1 0. Okay. You can add one more, like you can do all the numerical operations on it. So it is just a numerical vector. Okay. But are these really like that? 1 means pass for me. 0 means fail, right? Now what does this 3 comma 2 mean? It doesn't mean anything, right? Though they are coded as numbers, I want to treat them as two different classes, right? 1 means arrived, 0 means didn't arrive, okay? 1 means true or false, something like that, okay? So I can make them factors. So how do I make it factor? I'm storing it in result 1, okay? I'm factorizing, okay? Earlier it was treated as earlier result was treated as a simple numerical vector. Now I want to treat it as a factor, but I want to store, I don't want to overwrite it. I want to store it in a new variable called result1. So this result1 is not simply any vector. It is a factor, result1. What is the structure of result1? It's a factor with two levels, okay? Result 1 plus 2. Okay, it doesn't make sense because it has two levels. You can't add any numerical value. It's not a meaningful operator. The errors that I am talking about, okay, these are the kind of errors that you might get in your future, which you should not get, totally clueless. It says, it's a factor plus is not a meaningful operator for factors. Do you understand this error now, that you can't add any number simply to some levels of a factor? Got it? Yeah. There are some other lot of advantages of using factors, but anyway, this in here what I'm trying to convey is what is a factor variable. It is a variable that has different levels. It's a categorical variable. History and scripts. This is where you ask the first question, like how do we write a big R script? Okay, before that we will see how do we say. So till now you have run all the commands, right, everyone? Now can you send me all the commands in one file? If I ask you to give me everything that you wrote in this section, give me in one file. Can you give it to me? Can you send me all the commands that I think you wrote almost like 200 to 300 commands in this class? Can you give me all the commands? Say yes or no. So what you can do is you can access all the commands that are previously written if you go to history. If you go to history here, you can see all the commands that you have been typing till now. From first command, there are 212 more entries and all, till the latest command. This is called history. By chance, if you want the code to be rerun again, let's say if I want to write it again, I can double click on this and then enter. That is where history is. Okay, if you want to rewrite. Now one more important part, R source files and R scripts. Okay. Generally, when you are working with analysis, when you are working in a company, in a team, it doesn't work the way that we are writing the code here. You have to actually write the code in a notepad or in a source file, in a code file, store the code file. You have to write the comments inside that. You have to write the explanation. So for that, you need to write something called R source file. Okay. What is that? Let's say if you select few of the commands, you can send it either to console or you can send it to source file. So here is the R source file, or you can create the new source file as well. You go to file, new file, R script. This is the R script. Okay. So you write it as my, okay, class 1. What is this hash? This is for comments. Okay. If you write this will not be executed. Okay. So you write the commands here. Okay. What is the command? So one of the command is result C10. This is the code. Now how do I execute the code? I write it here. Okay. Let us suppose I write the full code. Okay. This whole code I want to write it. Okay. This is how I write the code. Okay. Earlier Suresh asked a question. What if I want to give a space? What if I want to give kind of explanation? Okay. Creating. So gender variable. Okay, what if I want to write like this? So this is how we write the script. How do we execute? So now here you can execute a specific part of the script. How do we do that? You can select that and you can hit on run. Okay, you can select that, you can hit control enter. Okay, so that way you write the code here, then you can save the code. You can select a particular folder, you can create your folder and say this is my first code. You can save the code. Tomorrow if I ask you, okay, let us start once again all the code, uh, can you show me the code that we were using it when we were discussing accessing data frames? If I ask you like that, you should be able to give me that code. Okay, you can save this script, you can save as, okay, my first code. Okay, you can select any of the so I'm saving it in my temp folder. You save it as my first code. Okay, it is stored in .r format. Okay, can you see that? It is stored in .r format and this is a script file, R script file. Is that clear? So history is this one. Generally we might not use history that much, but our script file is file, new file, script file, or sometimes you want to push some of the codes in the history. Like let's say I want to select 1, 2, 3, 4 lines. I want to push it to source. So it will come here. That means you have checked it. So maybe before writing the code, you directly wrote it in console. Whatever you write it in console, it will go to history. From history, you can push it, or from history directly you can push it to console and rerun the codes. Is that clear? You can get the code. I mean, you can write the code in source file, that is here. Sometimes you can bring the history commands into the source file or even console. History and script. Saving the source file, you can just click on save or save as, and it will be saved. How do we give commands in R? What do you mean by comments? Let's say you want to write something like creating factor or creating a new object is your comment, okay? And then you want to actually create the new object. Let's say C or like C1 to 30, okay? It's not a factor, so it's C is not a correct. So basically this one won't run because hash stands for comment. So within the script, if you want to comment out something, you can use hash. So it's a good practice to write whatever before writing the code. You always should explain what are you writing. Okay. Make sure you explain, let's say this is creating a new variable, new factor. Like that you need to explain, then only you should write the code. That is a good practice. Otherwise you will understand your code, the person who is consuming it, the person who is viewing the code might not be able to understand the code. Clear? We are done with this class for today. Till now we have been looking at some of the basics of R. Okay, in the next session we will start with one of the first R program that will finish the basics of R. I'm hopeful that you are very comfortable already with R, at least from the basics point of view, where to write the code, how to execute it, etc. In the next class, we will see some more basics, then we will quickly jump on to data handling. Okay.